Okay. Good afternoon, all. Yesterday we have discussed, actually we have started to discuss about how to calculate or how to determine the resultant force of a vector system. Okay. Under that topic, we have discussed what is a vector system. A vector system is a vector. If there are more than two vectors, we can consider the system as a vector system. Okay. Then we have discussed there are two ways or two methods to calculate the resultant force of a vector system. Under that topic, the first method, we have started to discuss the first method of taking the resultant vector of a vector system. Okay. So, what is the first method? The first method is the vector addition principle or vector addition theorem. Under that theorem, we can add any number of vectors. Any number of vectors. How to add? As we discussed yesterday, suppose there are four vectors A, B, C, D. According to our discussion yesterday, we did this addition 2 by 2. By 2 by 2, no? Okay. First, we add these two vectors. Then, we have taken the resultant of these two vectors and so we can replace these two vectors by its resultant force. Then, we have added the third vector to the resultant force of these two vectors. Okay. Then there will be another resultant vector, that is A plus B plus C. Then I can replace all these three vectors and consider that resultant vector. No, A plus B plus C. To that vector, I can add the fourth vector. And get the resultant vector of A plus B plus C and D. So, therefore, the resultant vector of these two is equal to A plus B plus C plus D. That means the resultant of all these four vectors. So, that is the way of doing addition according to vector addition principle. Okay. In that case, I have added 2 by 2. But we can do at once. How to do that? You have to coincide the end point and starting point of adjacent vectors. You have to coincide the end point and starting points of adjacent vector respectively. Then you will have a starting point and the end point. Then you can connect these two ends and get the resultant vector. Okay. Okay. Shall you do that? Okay. Look at the how to do that. You can coincide end point and starting point. End point and starting point of each vectors until the end vector. Okay, until the end vector. That is the procedure. Let's start to make coincide the first and second vector. Let's coincide the end point of the first vector with the starting point of the second vector. B coincide Z. Then coincide the end point of the second vector with the starting point of the third vector. D should be coincide with E. Then you will have this. then coincide the end point of the third vector and the starting point of the fourth vector. That means F has to be coincide with G. Then you will have this one. A, B, C, and D. This is H. Okay. Now you have coincide each and every vectors until the end vector. Okay. Then what do you have now? What do you have now? This is a geometrical shape, but it is not complete. No, it is not complete. There is an opening. There is an opening. This is the starting point of the first vector, and this is the end point of the last vector. Then you can connect these two vectors, connect these two ends. Okay, the starting point of the first vector with the end point of the last vector. Then from this vector, you will have the addition of these four vectors, A plus B plus C plus D. Okay. Actually, we have added this vector system by 2 by 2, but we can do that thing at one time. Okay. How to do that? You have to coincide the end points and starting points of vectors respectively until the end vector. Then you will have two ends. What are those two ends? The starting point of the first vector and the end point of the last vector. So you have to construct the vector from the starting point to end point. From that vector, you will have the resultant of the vector system. Do you understand that one? Did you get my point? I need responses from everyone, okay? This is the starting point. This is the end point. Okay. What about others? If you have any question or any unclear, then please let me know. හරිද? මේක තමයි වෙක්ටර් වල තියෙන හොඳම තැන. ඒක මම කිව්වේ. මොකක් හරි unclear තැනක් තියෙනවා නම් කියන්න. Okay. Okay. Then therefore we can write AF. AH, no? AH vector. Vector AH. Vector AH is equal to A plus B plus C plus D puta. Look at this. What is the point A? What is A? A is the starting point of the first vector. This one. It is the end point of the last vector. It is the end point of the last vector. Look at this. There's a relationship. No, there's a relationship. This is the starting point of the first vector. This is the end point of the last vector. Okay. Okay. We can note down this thing. Okay. Write a small topic. Write a small topic. Determining the resultant vector. Determining the resultant vector. determining the resultant vector of a vector system. Under that topic, previously we have discussed how to add vector system, how to add a vector system by 2 by 2. But we can do that at once. Okay. Write under that paragraph, in another paragraph, coincide the endpoints and the starting points. Coincide the endpoints and the starting points of vectors respectively until the n vector. Then construct the vector. From the starting point of the first vector. To the end point of the last vector. That is the resultant of the vector system. That is the resultant of the vector system. Okay. Draw this one. When you are drawing, please may draw this also. Point side, this one. Alright. Shall I clean the board? Okay. Others? Okay. Write a topic. Write a topic. Characteristic of the resultant vector. Characteristic of the resultant vector of a vector system.
Of a
Sorry?
of a
vector system. Characteristic of the resultant vector of a vector system. Characteristic of the resultant vector of a vector system. Okay. I para continue nak kawan. See. Okay. Suppose we are given this kind of vector system and then we have to add this vector system. According to vector addition theorem, how to add this vector system? We have to coincide the endpoint at the starting point, endpoint and the starting point of each vector respectively until the last vector. Okay. Then, if you coincide B and C, then you will have this one. Then you have to coincide D and E. D and E. Then you have to coincide G and F. Then this is H. This is H. Okay. Look at this one. Oh, what? Okay. Once you coincide the starting point at the end point, what kind of geometrical shape is this? What kind of geometrical shape? What kind of geometrical shape? Suppose I have construct the additional
a polygon.
Yes, very good. This is a polygon. This is a polygon because the number of sides are higher than the 4. Therefore, we can take it as a polygon. Okay. Actually, because there are 1, 2, 3, 4 and 5 sides. So this is a polygon. We can take it as a polygon. Okay. Actually, if I did not connect these 2 points, so this is not a polygon. No, this is not a polygon. Actually, this is a polygon, but there's an open side. There's an opening. That's an opening. Okay. Okay. So if you coincide B's end point and starting point each vectors until the last vector, then you will have a polygon, but it is incomplete. No, it is incomplete. So if you want to complete this polygon, you have to connect these two sides. No, these two sides. That means if you want to complete the polygon, you have to draw the addition vector. That means resultant vector. A plus B plus C plus D. That means the gap between the starting point of the first vector and the end point of the last vector is represent the resultant vector. That means the magnitude of the resultant vector is equal to the gap between the starting point of the first vector and the end point of the last vector. Do you understand that one? The magnitude equal to the gap between these two. Therefore, I can write that one. The magnitude of AH means resultant vector. H means resultant vector is equal to AH length. No, AH length that means the gap between, that means it is equal to the gap between A and H. The gap between A and H. A means the starting point of the first vector and H means the end point of the last vector. Okay, that is very important characteristic of vector polygon of vector addition theorem. So if, look at this one, if the resultant vector of a vector system is 0, what will happen? Tell me. If the resultant vector is 0, then what will happen? You can think according to this. What will happen? Yes. Very good. If the resultant force is 0, its magnitude should be 0, no? That is the obvious thing, no? If the resultant force is 0 of a vector system, that means the magnitude of the resultant force should be 0. No? If it is 0, if the magnitude is 0, that means the gap should be 0. There should not be gap. That means if I coincide all these vectors, then there won't be any gap. That means A and H will be coincide each other. No? Then we will have a complete polygon. Complete polygon. Do you understand that one? Everyone, I need responses. Everyone? Others? No? Okay. Suppose as example, we can take three forces. One is this one. One is this one. Other one is this. Suppose the resultant vector, the resultant force of these three forces are 0. Suppose the resultant force of these vectors are 0, that means if I coincide each and every vectors respectively, this is the starting point A, B, C, D, E, F. So I have coincide B and C, then D and E. D and E. Okay, then this is H. So this is F. This is F. This is A. Okay. Okay, the resultant vector of this vector system represents from AF vector, no? AF vector. Okay. If the resultant is 0, that means there should not be any gap. There should not be any gap. Gap at the end. So this gap should be completed. This gap should be completed. That means if the resultant vector of a vector system is 0, when you coincide the starting points and the end point, you will have a complete polygon without any gap. Do you understand the thing? තේරුණාද? I need your responses. තේරුණා මට කියන්න. Okay. So this is called as force triangle. When we are doing equilibrium, there will be another name for this one. Okay, there will be another name for this one. Actually, if you understood very well these theorems in vectors, actually you don't want to study. ඔයාලට නිකන් තේරුම් ගන්න විතරයි තියෙන්නේ. පාඩම් කරන්න දෙයක් නෑ මේකේ. හරිද? මම එකක් කියන්නේ මේ හැම එකේම බේසික් එක එකයි. මොකද්ද? vector addition theorem. It is vector addition theorem. If you understand vector addition theorem very well, then you don't want to study all the theorems. මොකද theorems අහන්නේ නැහැ පුතේ. ඔගේ theorems exam එකට අහන්නේ. හරිද? exam එකට theorem අහන්නේ exam එකට ඔයගොල්ලන්ගේ ගණන් හදන්න පුළුවන්. ඒ කියන්නේ දීලා question එක ඔයාලට කරන්න පුළුවන් දෙයක් විතරයි බලන්න. හරිද? ඒ නිසා if you want to do the exam question, you have to understand very well. Everyone should understand very well. Therefore, this is not a magic. This is not a rocket science. So you have to apply the vector addition theorem. You don't want to study another theorem in another name. Okay. මතක තියාගත්තට කමක් නැහැ name එක. නමුත් අපි අර complicated කරන්න ඕනේ නැහැ නේ. complicated කරගන්න ඕනේ නැහැ life එක. හරි? Okay. That is the first characteristic. Okay. The first characteristic. First one right under the topic. The gap between the gap between the resultant, sorry, the gap between the first, the gap between the starting point of the first vector, and the end point of the last vector. represents the magnitude of the resultant vector. The magnitude of the resultant vector. Okay, you don't want to draw this again because you have drawn this previously, no? So, but you have to write this one. H, the modulus of H vector, modulus of the H, that means the magnitude is equal to the modulus of R. R means certain vector. So that is equal to AH length. That means the gap between A and H. You don't want to draw this one, but just write this expression. Okay. Right under that. That means if the resultant vector is zero, the gap between A and H should be zero. The gap between A and H should be zero. So the starting point of the first vector, and the end point of the last vector, should be coincide. Okay. Draw this one as example. Okay. Once you draw this one, right under this, therefore, when coinciding the starting point and end points, when coinciding the starting points and the end points of vectors, we will have a complete geometrical shape. We will have a complete geometrical shape. Okay, look at the board. Everyone, look at the board. I need your attention. Look at this one. If the resultant is 0, this geometrical shape will be completed. No, it is a complete geometrical shape. Look at this one. These vectors are in order. No, it is in order. Suppose now it is in clockwise direction, so it is in a order. Puta. So normally we call it as a closed loop. It is a closed loop. No, there is no any gap. No, there is no any gap. Therefore, this kind of pattern, this kind of vector pattern is called as closed loop. Closed loop. If it is a closed loop, then that means the resultant of that vector system is 0. That is very important point. This is very important point because normally you are given a vector system with complicated shape. Within that complicated shape, normally you will have this kind of subsection. Okay. Normally you are given complicated shape. Suppose this one. Suppose there are another vectors like this. Suppose there are another vectors like this. So this is a complicated shape. No? This is a complicated shape. That means it is a combination of two shapes. One is a triangle, other one is a rectangle. So likewise, normally you are given some complicated shapes with some combination of geometrical shapes. Okay. So within that complicated shape, suppose there is a closed loop like this. There is a closed loop like this. Then you can decide the resultant force of that loop is 0 because it is a closed loop. Therefore, you can remove these vectors. You can remove this vector because the resultant is 0. Then you can consider these three vectors only. Okay. Therefore, this factor is very important factor, the closed loop system. Closed loop system. So if you have a closed loop system, that means the resultant is 0. Then you can remove that system. If you want to find the resultant force of a vector system, and you can see there is a closed loop, then you can remove that system. You remove that part, okay, because the resultant is 0. Then you can consider these three vectors only, okay. Okay. Do you understand that? Do you understand? මට තේරුණාද කියලා කියන්න බලන්න. හැමෝම මට මේ පොඩ්ඩක්. Okay. අනිත් අය? Okay. So if you have any closed loops, then you can consider the resultant vector of that closed loop is 0. Right under that, Puta, right under that. Thank you. Thank you. Right under that. This is a closed loop. This is a closed loop. Closed loop. Therefore, if there is a closed loop, the resultant of that loop is 0. The resultant of that loop is 0. Okay, අනිත් පැත්තත් හරි, okay. Reverse is also correct, okay. Reverse side is also correct. That means if the resultant is 0, then there should be a closed loop. If there is a closed loop, the resultant is 0. Both sides are correct. That's why there are two arrowheads. Both sides are correct. You can write this one and highlight that one. This is very important part in vector lesson, because when you are simplifying a vector system, this is a very important theory, closed loop system. Okay. How to identify a closed loop? How to identify a closed loop? If all the vectors are in same order, that is a closed loop. That means same order means if all the vectors are in clockwise direction or anti-clockwise direction, that means they are in the same order. So if all the vectors are in the same order, that means it is a closed loop. Okay, that is a way of identifying a closed loop. Closed loop එකක් identify කරගන්න එහෙමයි. බලන්න කට්ටියම ඉන්නේ clockwise ද නැත්නම් anti clockwise ද කියලා. හරි? Okay. Look at this one. In this vector system, if you go through this vector system, you will go in a clockwise direction, no? That may vector system clockwise direction without any interruption. Without any interruption, you can go in clockwise direction. So therefore, normally we call this as a this vector sign same order. So if the vectors are in same order, that means it's a closed loop. Right, small star and write how to identify a closed loop. How to identify a closed loop? Look at this one. These two are closed loop system, no? If you go through these three vectors, you will go into the clockwise direction. If you go through these vectors, you will go to the anti-clockwise direction. So these three vectors are in order, are in the same order. So these kind of vector systems are called as closed loop system. That is a way of identifying a closed loop. Suppose if we are given this kind of vector system, is this a closed loop? Is this a closed loop? No. If you want to go to this, what will happen? This vector is not in this direction. It is in opposite direction. So we cannot take this as a closed loop. Okay, we cannot. These two vectors are in order, but this vector is in the opposite order. Therefore, I cannot consider this as a closed loop. So this is not a closed loop. This is not a closed loop. Because this vector is not in the order. This vector is not in the order. This vector is not in the order. So this is not a closed loop. These vectors are in order. Therefore, these vector system are closed loops. These vectors are in the same order. Therefore, these are closed loops. These are closed loop. Draw this one. How do I identify closed loop? Draw this one. These vectors are in the same order. Therefore, these are therefore these are closed loops. These are closed loops. This vector is not in the order, not a closed loop. හොඳයි පුතේ මම මේවා පොඩ්ඩක් අර descriptive විදිහට කරන්නේ මොකද මේ මට මේක equilibrium වලට ඕනේ force equilibrium systems වලට මට මේක ඕනේ හරි මම ආයේ force equilibrium system වලදී මම මේවා කතා කරන්න ඕනේ නැහැ මොකද මේක දැන් descriptive විදිහට අපි කතා කරන්න තියෙන්නේ හරිද ඒ නිසා ඒවට ලේසි වෙන තමයි මේ ඔක්කොම කතා කරන්නේ අනික මම අය කියන්න ඕනේ පුතේ අර මම යන මේ මෙතඩ් එක පොඩ්ඩක් වෙනස් මොකද එහෙම නැත්නම් ඕගලන්ට අල්ලගන්න බැරි වෙනවා ඉස්සරහට යද්දී මොකද සිලබස් එකේ තියෙන විදිහට ඒ පිළිලු ගන්නන්න ගියොත් අනිවාර්යෙන් ඇනෙනවා ඒකයි මම කියන්නේ හරි ඒක නිසා ඕගලන්ට අර ලොජිකලි ඕගලන්ගේ ඔලුවට දාගන්න පුළුවන් විදිහට තමයි මම මේ පාඩම් ටික හදන්නේ හරි okay shall I clean the board yes if it is a closed loop the resultant is 0. There is another way to identify a closed loop. Okay. Actually, if it is a closed loop, what will happen? The starting points and or end points are overlaps, no? Until the last vector. Then the starting point of this first vector and the end point of the last vector are coincide. No? That is the way of identifying the closed loop, a closed loop. Okay. But it is easy to identify a closed loop using this method, no? Okay. Okay. That is the first characteristic. Second one is this one. Suppose okay. Suppose you have to add this kind of 1, 2, 3, 4 vectors. When you are adding these 4 vectors, what will you do? The starting point of the coincide with end point of the first vector coincide with the second vector. Likewise, end points and end points and starting points are coincide, no? Then once you coincide these starting points and end point, you can clearly see these vectors. These vectors are in the same order. The vectors in the vector system. The vectors in the vector system are in the same order. But the resultant vector, it is in the opposite order. No, it is in the opposite order. These are in the same order, but this is in the resultant is in the opposite order. That is another characteristic. So this is in the opposite order. Opposite order. But these forces, that means the forces of not only the forces, vectors in the vector system are in the same order, but the resultant is in the opposite order. Did you take my point? Clear now? This is another characteristic of our polygon. Okay. Okay. The second characteristic.
Yeah, is it like a rule for this? For the resultant force to be in the opposite side, is it like a rule?
It is not the rule, but I am discussing about characteristic. Okay. Previously, I have discussed about the rule. What is the rule? What is the rule? It is vector addition theorem. No, it is vector addition theorem. It is the rule. No, if you want to add 4 vectors, no, any number of vectors, you have to add according to vector addition theorem. That is the rule. Now I am discussing about the characteristic. Characteristic means if you look into this picture, what do you see? That is the characteristic. Okay. There, mother.
Okay, sir.
Okay. that is the characteristic. මේක characteristic පාඩම් කරගන්න එපා. Okay? Characteristic කටපාඩම් කරගන්න එපා. Don't study about characteristic. Okay? මේ characteristic කියා දෙන්න හේතුව මොකද ඕගොල්ලෝ picture එක දැක්ක ගමන් ඕගොල්ලන්ගේ ඔළුවට යන්නේ මොකද්ද මේ කියලා. ඒක. හරිද? picture එක දැක්ක ගමන් ටක් ගාලා grab කරගන්න ඕන නිසා තමයි මම characteristic උගන්වන්නේ. හරිද? This is not the rule. This is not the rule. Rule is the vector addition theorem. It is the vector addition theorem. We have done this up to this level using the vector addition theorem. Okay. Once you apply the vector addition theorem into the vector system, we will have this kind of polygon. Now I am discussing about the characteristic of this polygon. Okay. That is only. Okay. Okay. So therefore you can remember if the vector of if the vectors of the vector system is in same order and the resultant should be in the opposite order. You can remember that thing, but don't remember that only. Don't remember that only. ඒක මම කියන්නේ ඒක විතරක් මතක තියාගන්න එපා. මම ඒකයි මම මතක තියාගන්න එපා. මම මතක තියාගත්තා කමක් නැහැ. Okay? But ඒක විතරක් මතක තියාගන්න එපා. මොකද we have a theory. We have a theory. So we can use that one, but we can easily go for a question using this characteristic. Okay? Okay. Okay. හොඳ ප්‍රශ්න. හොඳ ප්‍රශ්නයක් ආපු. නැත්නම් ඔක මට අමතකුණා කියන්න මොකද්ද මේ characteristic කියන්නේ කියලා. හරි. Okay. Right. Under that. Once we apply the vector addition theorem, once we apply the vector addition theorem,
So this is for the second one.
yes, second one, under second one, okay, under second one, once we apply the vector addition theorem to a vector system, once we apply the vector addition theorem into a vector system, all the vectors in the vector system, all the vectors in the vector system all the vectors in the vector system
Sir,
Ah.
could you please repeat it?
sorry,
Could you please repeat the sentence?
once we apply the vector addition theorem, once we apply the vector addition theorem, once we apply the vector addition theorem to a vector system, once we apply the vector addition theorem to a vector system, all the vectors in the vector system are in the same order, are in the same order, are in the same order. But the resultant vector, is in the opposite order, is in the opposite order. Look at the sentence that I have given. Once we apply the vector addition theorem to a vector system. Okay, once we apply the vector addition theorem into a vector system, the vectors are in the same order. All the vectors in the vector system are in the same order. Okay, that is the theorem. Okay, then once we apply the theorem, this characteristic will be shown. Okay, once we apply the vector addition theorem into a vector system, all the vectors are in the same order. Okay, but the resultant is in the opposite order. Okay, they know this too. Once we apply the vector addition theorem, this characteristic will be there. Okay.
So is there a difference between the direction and order?
Yes, definitely. This is the direction. This is the direction of the vector. Okay. This is the direction of the vector. This direction of the vector is this one. This direction of the vector is this one. Direction this one. Direction of this vector is this one. Direction means it is it should be one certain direction. Okay. But order means if I coincide this one, all the vectors are rotated into clockwise direction, no? Into one direction, clockwise way or anti-clockwise way. So that is the order. Clockwise way or anti-clockwise way. That is the order. Okay. Direction is defined for a vector. Okay. Okay. Then another.
Yes, sir.
Okay. Then could you please draw this figure? Okay. Actually, once we apply the vector addition theorem into a vector system, you can clearly see now the geometrical shape of this vector addition is a polygon. Therefore, there is another principle, another theorem according to this geometrical shape. It is called as vector polygon theorem, vector polygon law. Okay. Actually, you don't want to remember that law, but you should remember there is a law, but it is not a separate law. That is vector addition principle. That is vector addition principle. Okay, but when we apply the vector addition principle into a vector system, The geometrical shape is a polygon. No? Therefore, there's another name. There's another name, and there's another law with another name. That is only. Okay. Okay. Write another topic. Vector polygon theorem. Vector polygon theorem. Vector polygon law. Vector polygon law. Vector polygon law. Right under that. Once we apply the vector addition theorem, into a vector system, we will have a polygon. We will have a polygon shape. Therefore, another law has been developed according to this geometrical shape. It is called as vector polygon law. Okay. Actually පුතේ මේ I have done previous class previous part because I want to write the vector polygon law. In vector polygon law, there is a word the vector sign same order and the resultant vector is in the opposite order. Okay. Therefore, in vector polygon law, that part is there. Okay. So if you want to remember the vector polygon law, you can remember that part. But I advise you don't remember anything. But if you can understand this very well, go for the basic understanding. Don't go for hard work. Okay. Okay. Right under this. If a number of vectors, if a number of vectors now we are writing the law, okay? So may write in another paragraph. Write in another paragraph. Now we are writing the law, okay? If a number of vectors can be represented in magnitude and direction, in magnitude and direction, in magnitude and direction, by the sides of a polygon, by the sides of a polygon, by the sides of the polygon, taken in the same order, taken in the same order, then they are resultant, then they are resultant is represented in magnitude and direction, by the closing side of the polygon, by the closing side of the polygon, by the closing side of the polygon, taken in the opposite order, taken in the opposite order. Okay. Write another topic. Write another topic. අතනදී ඔයාලට vector polygon law එක පාඩම් කරගන්න ඕන නම් පාඩම් කරන්න. නමුත් ඒකට vector polygon law එක කියලා කියන පුතේ වෙන මොකුත් නෙමෙයි. අර අපි ගත්ත vector addition principle එකම තමයි අර ඒක නිකන් රූප දිහා බලාගෙන ගත්ත විදියක් තියෙන්නේ. ඕකේ. ඒක නිසා ඒක මම ඒක ඇඩ්‍රස් දෙන්න පාඩම් කරන්න කියලා. නමුත් මම ආස තේරුම් ගන්නවට. So actually I don't advise to study the vector polygon law, but if you should have that knowledge. There is a vector polygon law, and vector polygon law is this one. That should be there. Okay, but when we are dealing with questions, I think it is better to go with vector addition principle. Okay, it is easy. It is easy. Or in vector addition principle, actually in vector addition principle or vector polygon law, there is only one thing to consider. No, only one thing to consider. What is that? The closing side. The closing side. That is only the thing you have to consider. If you represent a vector system in the same order, the closing side, that is the only thing you have to consider. So whether you can use either you can use vector addition theorem or vector polygon law. Okay, but in both cases you have to consider only one thing, that is the closing side. That is the closing side of a vector system. Okay. Okay. Then write another topic. This is the most important topic within this series. Okay. The factors to be considered. 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 The factors to be considered when applying this method to a question. When applying this method to a question. Okay. Suppose you are given this kind of geometrical shape. Okay. And it is given all the vectors in this vector systems are represented in magnitude and direction using this diagram. Okay. That word should be there. That word should be there. All the vectors should be represented in magnitude and direction. Those vectors, all the vectors should be represented in magnitude and direction. Okay. Otherwise, we cannot apply this method. Okay. I have told that earlier. If you want to apply vector addition theorem, you have to draw the vectors in magnitude and direction using a line segment. Therefore, these vectors should be represented in magnitude and direction by this geometrical figure. Okay. Suppose you are given this kind of vector system and ask you to determine the resultant vector. How to do that? How to do that? Now you can apply all your knowledge. Now you can apply how to determine the resultant vector of this vector system. Actually, now you have all the knowledge. You can solve this question without my help. You can solve this question, but I think you have to go for these kind of questions very quickly. Therefore, I will give you some tips. Okay. Actually, now you can do this without my help. Now you can do this without my help. Okay, because you have all the knowledge. But you have to go for this very quickly. Therefore, I will give these tips. Tip number one. Suppose you are given this kind of question, and ask you to find the resultant vector. The first thing you should determine whether there is closed loops or not. Whether there are closed loops or not. If there are closed loops, mark them and remove those vectors first. That is the first thing. If there are closed loops, then you can remove all the vectors from the vector system. Then you can reduce the vector system. Actually, the first tip. Suppose you are asked to determine the vectors, resultant vector of this vector system. What does that mean? What does that mean, Puta? The meaning of resultant vector is the meaning of resultant vector. Tell me the meaning of resultant vector. Everyone listen to me very carefully. Listen to me very carefully. This is because now I am give you a logic. Okay. Now I am giving you a logic. This logic should be understand very careful, very real. Okay. Okay. What is the meaning of resultant vector? What is the meaning of resultant vector? මොකද resultant vector කියලා කියන්නේ? Tell me. I want an answer from you. I want an answer from you. තංගාල උත්තරයක් කියන්න නැත්නම් මං ඉන්නවා. So what is the vector? What is the resultant vector of a vector system? දැන් පොත් බලන්න එපා, පරණ පොත් බලන්න එපා, මම ඕනි පොඩ්ඩක් මතකයෙන් කියන්න. What is the resultant vector of a vector system? You can give the answer in the chat box, or you can unmute yourself and tell me the answer. Yes. Yes. That is the correct answer. The single vector that can use instead of all these vectors. The single vector, okay? That is the word, okay? That is the word. That the word should be there. The single word that can be used instead of all these vectors. Okay? When we are doing when we are adding two vectors, we have defined the vector. When we define the resultant vector, no? At that time, we have said the resultant vector of two vectors, that may mean the vector that can be replaced the two vectors. Now, there are more than two vectors now. So, resultant vector of that vector system means the single vector that can be replaced, that can be used instead of this vector system. That means you should listen to this logic, okay? Make a very carefully. That means you have to reduce now 1, 2, 3, 4, 5, 6, 7. There are 7 vectors now. So you have to reduce these 7 vectors into one vector. That is the meaning of finding resultant vector. Okay. What is the resultant vector? Resultant vector is the single vector that can be used instead of all the vectors in a vector system. So, if you are asked to find a resultant vector, that means you have to reduce all these vectors into one single vector. One single vector. How to reduce that one? That means you have to reduce the number of vectors, no? You have to reduce number of vectors. How to reduce that one? That thing can be done using 3 methods. The first thing is, as I said earlier, the closed loop system. You have to look into this figure and find whether there is a closed loop or not. If there is a closed loop, that means the resultant force of those vectors are 0. Therefore, you can remove those number of vectors. That means there will be a lot of reduction of vector. No. Therefore, you can reduce a bulk of vector at once using that method. You can remove a bulk of vector. Vector ගොඩක් එකපාරවල remove කරගන්න පුළුවන් ඒ method එකකින්. Okay. So you can remove a bulk of vector at once from that method. What is that method? You have to look into the figure and determine whether there is a closed loop or not. Look into this figure. Tell me whether there is a closed loop or not. Closed loop or not. Yes or no? Give me the answer very quickly. Yes. Others? Yes. Others? Is there any closed loop? Please tell me what is the closed loop. That is my second question. What is the closed loop? Tell me with English letters.
EDC.
A, B?
EDC.
E, D, C. Yeah, it is a closed loop. It is closed loop. Is there any closed loop? Yes? EDC is one closed loop. Yeah. Is there any other closed loop? Any other suggestions? A, B, C. A, E, C. A, E, C. Yeah. Normally, when you are telling a closed loop, please tell me in a order. A, C, E. Then D, E. Sorry. C, D. Is you have said C, E, D. This one C, E, D. It is not a closed loop. C, E, D. This one is not a closed loop. A, C, E. Yes, that is the answer. The entire outer surface, and the entire outer surface is a closed loop. Look at this. This one, dish. Go from this one. Ding, dush. The entire loop, the entire outer loop, okay? The entire outer loop, A, B, C, D, E, is a closed loop. Yes, most of you are correct. There are some small closed loop there, but the largest closed loop is A, B, C, D, E. This one. That is the largest closed loop. Therefore, you can remove this one. Okay. You can remove this figure, this force, and this force. Then there will be only two forces. What are those? AC and AC and EC. There are only two forces there. One is AC, other one is CE. Now you can apply vector addition theorem into this figure. No? Vector addition theorem or vector triangle principle, both are same, or vector polygon principle, all are same. If you add vector triangle principle, so the addition of these two, look at this. These two vectors are in order. Therefore, their resultant should be in the opposite order. Therefore, the resultant force. Sorry?
Can't we take AC plus CE plus EA
Wait. AC
plus
yeah.
CE plus
Yeah.
EA plus
EA.
AB plus BC plus
No. It is not a polygon. No? If it is a polygon, it should be a polygon. Okay.
Okay.
Closed loop means that should be a polygon. Okay. The outer. Okay. Okay. Therefore, the resultant vector of this vector system is AC. AE. Do you understand that one? Everyone, I need responses. Everyone, I need your responses. AE. R is equal to AE. Others? I need responses from everyone. Yeah. Okay. I need responses from everyone because this is the most critical part of the lesson. Okay. The first thing we have to do, you have to identify a closed loop. Closed loop means a polygon. Okay. It should be a polygon. It should be a closed polygon. If you identify a closed polygon, then you can remove those forces or vectors. Okay. Then you can reduce the vector system into a lower number of vectors. Okay. Once you reduce the lower number vector system into a lower number of vectors, then look again whether there is another closed loop or not. If not, you can apply the vector addition theorem. Or that means vector polygon or vector triangle principle. Okay. Both all are in same theory, no? Okay. Therefore, the first thing is you have to identify whether there is a closed polygons or not. Once you identify the closed polygons, then remove all forces in the force polygon. Then finally, no, actually you can apply the closed polygon again and again, if you can see more polygons. But the most important thing is closely look into the figure and take the largest polygon. Take the largest polygon, because if you see the largest polygon at once, then it is easy. Then apply vector triangle principles or vector polygon law to reduce number of vectors into one vector. Okay, that is a way of doing this kind of question. Okay, right under the topic. Right under the topic. Resultant vector. Resultant vector.
Can you repeat the topic?
Topic is whatever. Can anyone say the topic? Okay. The factors to be considered. The factors to be considered. The topic may be changed with the first topic. Okay. Then again, I'm saying another one. The factors to be considered. The factors to be considered when applying this method. When applying this method into a question. The factors to be considered when applying this method into a question. Right under the topic. The resultant vector. The resultant vector of a vector system. The resultant vector of a vector system. The resultant vector of the vector system. Of a vector system is the single vector. Is the single vector that can be used. That can be used instead of all the other vectors. Instead of all the vectors in the vector system. Instead of all the vectors in the vector system. That can be used instead of all the vectors in the vector system. Therefore, therefore, when finding the resultant vector, when finding the resultant vector, when finding the resultant vector of a vector system, we have to reduce, we have to reduce the vector system into a single vector. We have to reduce the vector system into a single vector. Then look at this. Look at the board. Actually, there. Now, our aim should be reduce this vector system into single vector. No? Therefore, we can apply the previous theories to reduce the vector system into a single vector. Okay. My first point was apply check whether there is a closed polygon loop or not. If there is closed polygon loop, that means the resultant is 0. That means cross vector can be omitted. Then once you omitted those kind of forces, then look into vector polygon principle. That means vector addition principle for more vectors. Not only 2 by 2. Go for more vectors, because if you can remove more vectors at once, that will be a plus point. Suppose this one. Suppose if any student take this loop EACD, it is also a closed loop. No? If any student see that loop and remove those forces, if any student see this loop EA, AC, CD, DE, it is a closed loop. So suppose if any student see that loop and remove those forces, then he or she will have this kind of vector system. Those are the remaining vector system of that student. Then there are 1, 2, 3 vectors. Then he can apply either triangle principle or polygon principle. Both are vector addition principle. Okay. But suppose this one. If you remove these two forces at once and then you add the resultant with this one, then you have to do 2 steps. Okay. So once you reduce the force into some certain force system, then go for vector polygon law. Vector polygon law means if you can remove more vectors at once, go for that one. Look into this. Those 3 forces are in order, no? those three forces are in order. If they are in order, definitely now they they are in the vector addition principle, no? Because if they are in order, their endpoints and starting points are coincide respectively. Okay, that is the way of doing this. So if they are in order, then definitely I can connect the starting point, the end point of this one and starting point of the first vector and take the certain force. Take the certain force. That means if you apply the vector polygon law, these three forces are in order. Therefore, the opposite order in this gap gives the resultant vector. Okay. Therefore, once you apply the closed loops method, then you will have a reduced vector system. Then go for reducing more vectors. Put. That means if you can apply vector polygon law, then go for the vector polygon law. Then try with vector triangles. Finally. Okay. Right under that. Therefore, we can apply the following methods. To reduce the number of vectors, from the vector system. Factor number one. Check whether there are closed polygons or not. If there is a closed polygon, the resultant force, the resultant vector the resultant vector of those vectors is zero. Therefore, we can remove all the vectors of that vector polygon, of that what vector polygon. The second apply vector polygon or vector triangle law. Vector polygon or vector triangle. Vector polygon and O vector polygon and O and slash O. Vector polygon and slash O. Vector polygon or vector triangle law. To reduce the remaining vectors, into one single vector.
To reduce
remaining vectors to reduce the remaining vectors into single vector.
remaining vectors to reduce?
No. We can then apply vector polygon and or vector triangle law to reduce remaining vectors into a single vector. Okay. The second part, apply vector polygon and or vector triangle laws to reduce the remaining vectors into a single vector. Man can speed ready there. Eh? Okay. Once you finish writing, this is the example. You can draw this figure. Then this is the way of writing. Now ABC, AB, ABCD is a closed loop or closed polygon. I think that word is very good. Polygon. Otherwise, there will be confusion. Closed polygon. Therefore, AB plus BC plus CD plus DE plus EA is 0. So these vectors can be removed. Actually, you don't want to write this one because normally you are given this kind of questions in MCQ paper. Therefore, you don't want to write this one. But as this is example, we have to write this one. Otherwise, we don't know how you simplify this one. Therefore, write this one. But suppose if you are given this kind of question in term test paper, in the second essay paper or the structured paper, if you are given this kind of vector system in your exam paper as a essay question, if you are given as this as an essay question, then you have to write this one. Normally, you are not given this kind of question in the exam for essay paper, but you may have this kind of questions in MCQ paper. Therefore, no need to write this one. But normally, I think in first term test you will have this kind of questions because there's very limited syllabus to cover in first term. Therefore, you might have this kind of question in your first exam. Okay, these vectors can be removed. Then there is this kind of vector system. This is E, this is A, this is okay. If you add vector triangle principle or vector addition principle, if you add vector triangle principle, look at this. These two vectors are in order. Therefore, the resultant vector should be in opposite order. So this should be the resultant vector. It should be the resultant vector. So applying vector triangle law. AC plus CE. AC plus C. AC plus C. Look at this. AC plus C. Look at this. The end point. The end point and the starting point are same. That means they are coincide. They are coincide. Therefore, the result should be from this starting point to this end point. That means AE. AE. Therefore, the resultant vector is A. Okay. Once you complete writing, do these 3 questions. Fourth one. Find the resultant force of this vector system. Okay. Okay. ටක් ගාලා කරලා මට answers ටික එවන්න. ටක් ගාලා කරලා answers ටික එවන්න. Please do it quickly and send me the answers. Yes. Very good answers. First one. Please look at the first one. First answer. Other two are okay. First answer. First answer. Again, the first answer. Is it AC or CA? Is it AC or CA?
CA.
CA, ne? CA. Hmm? Look at this. Look at this. This path. If you go in this path, the entire outer loop is a closed loop, no? A B C D A is a closed loop, no? You can remove all these 4 vectors. You can remove all these 4 vectors, then the remaining is CA. The remaining is CA. Fair enough, Did you understand? The remaining is CA. Okay. Then other two are correct. In this case, this is a closed loop. This is a closed loop, ne? ADCA is a closed loop. Or otherwise, ABCA. It also a closed loop. You can take either one. Okay. So if I take this one, ADCA, I can remove these 3. If I remove these 3, I will have AB and BC. AB plus BC means AC. It should be AC. It should be AC. So resultant of the second graph is AC. This is the easy one, no? This is the easy one. All the vectors are in order, in same order. So this is a vector polygon, incomplete vector polygon. So if you want to find the resultant vector, you have to complete that one. That means you have to draw a vector from the starting point to end point. The starting point of the first vector to the end point of the last vector. Therefore, the answer for final one is AD. There another. I need responses from everyone. Do you understand that one? Answers? Others? Others? Okay. Steve?
So in the third one, how should we write it?
No, you don't want to write anything. I just want to write, may get the answer. But if you want to write it, you can write this one. No? AB plus BC plus CA plus with a number n ABC. Suppose this is E. Then AB plus BC plus CE plus ED. Then answer is AD. Look at this. Outright. AB vector plus BC vector plus CD vector plus not CD ne CE ne CE vector plus ED vector. Those are the vectors, no? Those are the vectors in the method one. So this one, end point and starting point are coincide. End point and the starting point are coincide. End point and starting point are coincide. Therefore, the answer is the starting point and the end point. Answer is the starting point of the first vector and the end point of the last vector. Those will be cancelled out. Those will be cancelled out. So therefore, remaining points are A and D. So this is the starting point. This is the end point. So this is the vector. This is the resultant vector. That is the way of thinking. Okay, way of thinking is starting point and the end. Maybe this is the end point. This is the starting point. End point and starting point. End point and starting point are same number, same letter, same letter. That means they are coincide. If the starting point of the first vector, if the starting is end point of the first vector and the starting point of the second vector are in same letter, that means they are coincide. Okay, they are coincide. They are coincide. So all of them can be cancelled out. That means remaining. Okay. Then go for this one. Give me the answers. Okay. Others? I want the answers from everyone. What about others? Loops අතරේ පැටලලා දින කට්ටියද? ඈ? Loops යන්න ගිහිල්ලා. Sorry. First one. First one. DC or 2DC? The first one. Fourth one. Fourth one. DC or 2DC? Okay. Shall we go for the questions? The fourth one. Look at this. Actually, now there is no any closed loop, no. Therefore, the first step, I cannot choose that one. Then go, no, now I have to go for either vector polygon or vector triangle principles. Vector polygon. Here, this one, no. No three forces are, no three or more than three forces are in same order. Therefore, I have to add 2 by 2. This one and this one. I can add this one. So, if I add this one, it is AC, no? It is AC. So, I can remove this one. Okay. Then I can add this one, no? DE plus EA. DE plus AA. Same order, in same order. Therefore, if I add these two, it will be DA. So, I can remove this one. Therefore, there are two forces now. Three forces are there. What are they? DA, EC, DA, EC, and DC. So if I add DA and EC, if I add DA and EC, it should be DC, no? It should be DC. If I add DA and EC, AC, it should be DC. Now I can remove these two also. If I remove these two, now there are two forces. What are those forces? DC and DC. There are two DCs. So the answer should be 2 DCs. Another?
Sir, how does 2DC come?
Okay, I will explain. Okay. Look at this. This is my figure. A, B, C, D, E. Okay. Look at this one. Look at the figure. Okay. Now there are no any closed loop. Therefore, I have to go for the basic triangle principle or polygon principle, polygon law. But in this case, polygon law cannot be applied because there are no more than two forces in order. Therefore, the only method is triangle principle. Okay. So if I add these two, look at this. These are in order. Therefore, I can add these two and the resultant would be AC. Resultant would be AC. Therefore, I can remove these two legs. Okay. Now resultant is AC. Then, if you look into this figure, you can see ED and EA. ED and EA. These two forces are in order. These two forces are in order. No? So if I add these two forces, that means the resultant is should be DA. It should be DA. Okay. So I can remove these two also. Now I reduce the vector system into three vectors. Three vectors. Look at this. If you look into this figure, you can see ding dings. That means EA and AC, EA and AC are in same order. Therefore, if I add EA and AC, it should be C. It should be DC. It should be DC. Okay. Therefore, I can remove EA and EC. Now, how many forces are there? There are two vectors. What are those? DC and DC. DC and DC. That means 2DC. Okay. The result is 2DC because both are in same direction. Both are in same direction. Result is 2DC. Terium. No other.
Okay, sir.
Others? Oh, I need
Yes,
responses.
sir.
Okay, Puti. Then go for the second question. Second one is much easier than the other. Look at this. AB, BC, CA, DA, EA, the outer surface. Outer polygon is a closed loop, no? Therefore, you can remove all these forces. Then there will be only two forces. What are those? EC and EB. EC and EB. There will be only two forces. What is that? This one and this one. Therefore, these are in order. EC and EB are in order. Therefore, the resultant should be, what is? CB. It should be CB. Therefore, the answer for second one is CB. CB. තේරුණාද එක? Okay. This one for here. To this direction. Into this direction. Into this. This one. A, B, C, D, E. Okay. Last one. Are there any closed loops? Tell me. Are there any closed loops? Are there any closed loops? Are there any closed loops? Yes. What are those? What are those? A, E, yeah. Good. There is one. Yeah. This one. A, E, D, C. That is a closed loop. Yeah. A, you can see me. A, E, D, C. It is a closed loop. Ding, 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 ding. Closed loop. Zing, 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 zing. Closed loop. So I can remove these four forces because it is a closed loop. Okay. Then there's another closed loop. What is that one? B, E, C, this one, I will write in another pen. This one, and this one. They are in order. Therefore, it is a closed loop also. This one and this one. So these three forces can be removed too. So after removing all these forces, there is only one force. What is that? AB. What is that? AB. Therefore, the resultant is equal to AB force. AB vector. Okay. Theorem. Another. Okay. Others?
Yes, sir.
Puta? Okay. Now we are going to complete today's lesson, Puta, because now it is not there's no enough time to start the other, because we have to go for the next session from 7 to 10 p.m. Okay, listen me very carefully. Please let me know if you have any questions regarding today's lessons. Please let me know, because this is a very important lesson, because most of the questions in vectors in past papers are based on this section. Okay, finding resultant force of a vector system. Okay, so this is the most important lesson in the vector unit. Okay, so if you have any questions, please let me know.
Sir, can there only be one resultant vector?
Sorry?
Can there only be one resultant vector?
That means?
I mean, can there be two resultant vectors?
No. What is the meaning of
Only
resultant
one.
vector? What is the meaning of resultant vector? It is the single vector that can be replaced all the vectors of the vector system. Therefore, according to the definition of vectors, resultant vector, it should be the single vector. Okay? It should be the single vector. Therefore, there won't be two resultant vectors. There should be there should be only one resultant vector. Okay? If you have
sir.
two vectors, that is not the resultant. If you have two vectors, that is not the resultant of the vector system. Okay? According to the
Okay, sir.
definition, yeah, very good question. According to definition of resultant, that means it is the single vector that can be replaced all the other vectors. Okay? Therefore, it should be the single vector. It should be a single vector. Okay?
Okay, sir. Thank you, sir.
Okay. Others? No. Okay. Okay. Then our next class will be Friday, no? It is on Friday. In this next class, we are going to complete. If we can complete, we are going to complete vector lesson. Then we can do the questions on Sunday class. So Friday class also import class. Okay, then we can complete the lesson. Another thing. Actually, there are some students they inform me that they cannot come to the Monday's class. So if you want to change this date, then now there are free time slots from me, because now 2023 students is gone. No? Therefore, now there are free time slots. So I will ask within the group if you want to change this date, because Monday will be a permanent day, Puta. Monday will be a permanent day. So there will be a important lessons that can that will be teach in Monday's class. Okay. Therefore, Monday will be a permanent day. Therefore, if you can, all the students, if you can participate, all the students should be participate for live classes. Okay, because after these lessons, most of the important lessons will be discussed in Monday's class. Okay, therefore, if you want to change this date, I will ask about that too in the class group. So I will open a poll. So So please vote for that one. So if you want to change that one, then there will be another free dates, which is on Tuesday and Friday. So I'm free on Tuesdays and Fridays as well as Mondays. Okay. So among these 3 days, you can choose one day as a permanent date. So it will be the permanent date until 2025. Okay. Therefore, it can't be changed after that. So considering all the factors, please vote for that. Okay. Okay. Then thank you everyone. We will discuss the last lesson of algebra from 7 p.m. to 10 p.m. Okay. Okay. Thank you. Then okay. Goodbye. Bye bye.
Thank you,
Thank you,
sir.
sir. God bless you.
God bless you. Bye.
Sir,
Yes, do.
sir මේ මං අර සර්ගේ අර ෆස්ට් ලෙසන් එක බැලුවා YouTube එකේ. එතකොට සර් පොත් තුනක් ගන්න කියලා